All right, hello and welcome back to Algebra. We are talking about equations today. And since equations are kind of like scales, I have busted out these scales to illustrate what I'm talking about. So, first off, we're going to talk about the addition property of equality. Okay, so if this is an equation, this bear is equal, we can see it's balanced here, is equal to about 9 cubes. Now, if I add something to one side, so I have a stack of 3 cubes here, if I add that to one side, we're no longer balanced. Okay, but if I add the same thing to the other side, now we're balanced again. All right, so I can add the same thing to each side of an equation. Think of this as an equation. There's an equal sign in between these two, and it remains the same. So, the addition property of equality. You can add the same number to each side of the equation, and the equation remains true. So if you have A equals B, you can add C to each side, and that's still true. Or 9 equals 9, we added 3 to the side, and now we have 12 equals 12, still true. Same thing happens for subtraction. You can subtract the same amount from each side. For example, if I take off 3 from this side, now we're not balanced, but if I take off the same amount on that side, then we're balanced again. Okay, so the subtraction property of equality. You can subtract the same number from each side. So, A minus C, B minus C. So if we have 9 minus 3, for example, 9 minus 3 would be 6. 9 minus 3 is also 6. So they're still equal. There you go, subtraction property of equality. Now, what about multiplying? Well, I could multiply this by 2 and say I put a bear on that side. Okay, now I have 2 bears. I multiplied by 2. Now I have to multiply this side by 2. That means I need to put another 9 on there. So double that. There's 3, 6, 9. All right, and now we are balanced again. Okay. So, this should say multiplication property of equality. All right, let's try that again. Multiplication property of equality. You can multiply each side of an equation by the same number, and the equation remains true. So if A equals B, then A times C equals B times C. Or if 9 equals 9, 9 times 2 equals 9 times 2, which is 18, equals 18. All right, let's see. What about division? Let's try to divide these. Okay, 2, woo, there we go. Aha, 2 divided by 2. Well, that means take 1 off. It would tip down, but then we take off half of these. 1, 2, 3. And there we go. They are balanced again. So we divided by 2 here, and that remains true. So that gives us the division property. Division property of equality. You can divide each side of an equation by the same number, and the equation remains true. So A divided by C is equal to B divided by C. Or if we do 9 divided by, let's make it easy, divided by 3 is equal to 9 divided by 3. 9 divided by 3 is 3, and that is equal to 3. And ladies and gentlemen, those are the properties of equality. To solve equations, we use these, and we use inverse operations. We use inverse operations to solve an equation. So, if we have x plus 3 is equal to 12, what's the inverse operation? Subtraction. We're going to subtract 3 from each side, and x equals 9. If we have y divided by 3 equals 2, what's the inverse operation? Times. So we're going to multiply each side by 3. Y is equal to 6. If we had a minus 5 is equal to 20, we want to add inverse operation plus 5. So a is equal to 25. And then finally b times 4 is equal to 12. Divide. So we use the inverse operation. B is equal to 3. And that's simple solving equations.